If you want to believe what NASA says, let's go to NASA's website right now. Look up where just the Arctic has increased between 82 and 112 billion tons of ice per
That's
year on either one of the poles. There's, if you look at the historic records of photographs from space, you can actually see that the polar ice caps are increasing in size. So there's, the data is overwhelming. The problem is getting people to look at the data. When you look at sunspot activity, we've been doing this for well over 400 years. When the second peak of the solar cycle is higher than the first peak, we start the sun going into an extreme cooling phase. It's been this way for centuries. That's just the way the sun works. And during our last solar cycle, that's what we had. We had our second peak was higher than our first peak. And if you look back through charts of sunspot data, each time that we go into one of these cooling periods, you get that second peak being higher than the first peak. And you can look at it back in the Maunder minimum, the Little Ice Age. All of these cold climate events have been, you know, a decrease in solar activity. There's lots of places that you can go and look at the SDO, the Solar Dynamics Observatory, and just take a film. I mean, look, the SDO has been up there for years. I mean, not decades, but years. It's a new sensor to us. And you can look at it and you can actually see the sun becoming weaker in the uh, in the SDO images. We also have the increased particles that are galactic rays and galactic particles, things that are coming into our solar system from outside of our solar system, because the external stream of energy coming off of the sun has already decreased by well over 35%. So particle speeds are down, which means that our heliosphere is not pushing those particles out away from our solar system like it used to, and is allowing more of those to come in. So because the sun is weaker, we get more particles from the universe. Because our magnetosphere is weaker, we get more particles from our sun and the universe. we're dealing with the Milosevic cycle of where our orbit changes and we move farther away from the sun. And then when we move farther away from the sun, we're getting more snow in the northern hemisphere. Then when we come back in, which is summertime in the northern hemisphere, that energy is not being absorbed by the planet, but it's being reflected back out into space because so much of the northern latitudes are being covered by snow, and snow refracts almost 25% of thermal energy back into space. You can look at Heinrich Svenmark. Heinrich Svenmark is a physicist who has came up with a theory called the cloud mystery and explains how clouds increase as we go into these solar minimums because we get more particles in our atmosphere. Now that's peer reviewed, that's proven. What they do is when they come into our stratosphere and they come in, they're highly charged. And what that does is because they're so highly charged, they bond with oxygen molecules. So you have, a hydrogen molecule and two oxygen molecules, and they get together and they create a water molecule, which is known because it's floating around as an aerosol. So those aerosols, um, they continue to make more clouds in our sky and they stack up on top of each other. And, you can see it. It's not a thing of, oh, that, how can you see it? Well, go outside today. If you watch the sun and you look at the coronal holes, which are massive, by the way.
Yes, they are.
If you wait 96 hours and then go outside and look up, you'll start to see these real thin layers of gray clouds up above us. And what that is those highly charged particles coming into our atmosphere. Now that increases the aurora borealis, that increases the amount of energy that is coming down through the Birkeland currents, and that increases the amount of clouds. Well, there's a lot of things different about this one than ones we've had in the past. Um, Ones we had in the past, we didn't have the decrease in solar wind speeds from the sun like we have now.
Okay.
And so those decreases in solar winds are letting a lot more cosmic rays in. Um, Also, we didn't have a decreased magnetosphere like we have this time. And so that is letting a lot more winds in, or solar winds and solar particles into our atmosphere. And that is increasing our cloud cover.
Whatever.